Okay, so this is 4.1 Polynomials, Part 3. We're going to talk about finding zeros of factored polynomial functions. We are given a function here that says x squared minus 2x minus 8. Its factors to x plus 2 and x minus 4. Finding the zeros, all we do is we're going to take the factored form and set it equal to 0. When we do that, that means either this one is a 0 or this one goes to 0. We accept that the answer is going to be both. So when we have x plus 2 equals 0, when we go ahead and we move that 2 to the other side, we're going to subtract it. So our x is going to be a negative 2, and in this case, our x is going to be a 4. If we have 4 minus 4, that does go to 0. All right? So again, we have functions that can be factored. There's another one here. Function of x cubed plus 2x squared minus 5x minus 6 can be factored. And it can be factored to x plus 3, x plus 1, and x minus 2. Each of those in the quantities. Okay, so finding the zeros, again, we're going to set each of these groupings equal to 0 and solve. So in this case, our x plus 3 becomes x equals negative 3, and x plus 1, our x is going to be negative 1, and for x minus 2, the x is 2. Finding those zeros, it's pretty straightforward. We will know on our number line, right? We would know where our process is going to happen. So we have a place where either it just bumps into or it crosses over. Now in this case I have to the third, so it's not going to just bump into. It actually goes it goes up like this, and then we have something that does that. And again, this is just a really general form here that I'm making, but it would go through each of those 3 points. All right, so what happens when we have multiple factors that they're the same factor? Well, we're going to talk a bit about that. And I want to caution people because there's a piece here that it's real easy to confuse degree with multiplicity, and we'll talk about both of those things, and I'll show you how you can kind of pause and think and keep track of which one is which. So here we have the zeros. We're going to find the zeros. We have a 5, right? And then I'm going to have x minus 2, x minus 2, x minus 2, right? So that's going to give me an x minus 2 quantity cubed, and then x plus 1. And I'm going to point out that this is to the first power, right? So if we take it, just take a moment and pause and think. For my degree, I have a 3 plus a 1. That's going to give me my degree of 4. All right, which is what we would expect. Right, we have x and x and x and x. So potentially, well, you should have something to the 4th power, right? And that gives us our degree. Now, we're going to talk about the multiplicity of things. Multiplicity talks about how many times that same factor multiplies itself. In this case, our multiplicity is 3. Okay, it's going to be an odd, and we'll talk about how that behaves here in just a moment, but I want to make sure that we're really clear. The multiplicity on this is 3 and the multiplicity on this is 1. All right, and here I'm going to go ahead and do the same sort of thing. I'm going to have a negative out front, a negative 1, and then I'm going to have x minus 1 quantity squared, and then I'm going to have x plus 2 quantity squared. Now again, if I take my exponents on this, I have a 2 plus 2. That's going to get me my degree of 4. All right. So in this case, I have a multiplicity of 2 and a multiplicity of 2. All right. So what is multiplicity? Well, when we have our exponent on the term greater than or equal to 1, and there is no term that has a bigger exponent. Okay? The k, when the exponent is odd, the graph crosses our x-axis. And it's going to cross at whatever our value is, whatever we solved x for. So we'd have our x value when we have solved it is in 0. If k is even, okay, so in this case, this multiplicity is odd and this multiplicity is odd. So we're saying that in this particular case, we are going to have the line cross the x-axis at 2 and -1, right? So if I were to solve for this, I would have my x minus 2 equals 0. So that would be x is going to equal 2, right? Pretty straightforward there. And again, my x plus 1 equals 0. And then that's going to become an x minus 1. All right, so in those cases, it's pretty straightforward. What we're going to have is we're going to have either it crosses, as in this case, we're going to have the 3 and the 1. Those are going to cross, or it's going to just bump into, just touch the x-axis, because we have an even multiplicity on our term. All right, so in this case, again, you'd have the x minus 1 equals 0. That's going to give us x is equal to 1. And then here I'm going to have my x plus 2 equals 0. So that means my x is going to equal -2. All right. So in these cases, and we're going to take a look at these actual graphs here in just a second, but I wanted to make sure that we're understanding the difference between degree and multiplicity, right? So our degree, we have to take a look at all of the terms in here, right? So if I've got this is to the 3rd power and this is to the 1st power, add those two together, I get my to the 4th. That's my 4th degree. This is again 2 and 2. That's going to get me a 4th degree. Up above, each one of these had a multiplicity of 1, right? So all of those are actually going to cross the x-axis, it's helpful to know that, okay? So if we take a look, first of all, we have a degree. Our degree was 4, right? And in this case, we have a degree equal to 4 as well, right? So in this case, we are going to expect it to behave along the same lines, generally speaking, as a parabola. This is going to, since my my coefficient on this whole thing was a 5, way up here, right? That 5 is a positive value. I'm going to have an upward facing, something that's curved in the big picture. It's going to be like a parabola, which this is, okay? Now, we take a look here, and I'm going to put this in red so it's real easy to see. So here is the -1, and here is the 2. Those are the points where we actually cross. Now remember, these have odd multiplicities. So these both have odd multiplicities, so they're going to actually cross. Here we had an even multiplicity. And we have multiplicity. There. Okay, so multiplicity, our even multiplicity says that it's only going to touch, and here is exactly what it does. It touches here and it touches here. It never crosses the x-axis in those two, in this particular case. All right, now It's possible to have something where you have a, and I'm just kind of making this up as we go, so it's possible to have like x plus 3 squared and then have an x minus 5 quantity cubed. All right, and so you would have a you would have an even multiplicity and an odd multiplicity. So in this case, it's only going to bump into our value at -3, and in this case, it will cross at +5. Okay, so in this case, our odd multiplicity and our even multiplicity, that's for the whole function, but it is possible to have some of both. Okay, so I want to be sure that people know that. All right, so I want to mention that we're going to come back to this idea of figuring out what's happening in our graph using intervals, right, and finding out where the function crosses the axis or touches the axis. We're going to talk more about that in 4.2. So it's just kind of a little brain push towards 4.2. All right, so I'm going to go with the fact that some folks had some questions about factoring. I'm going to end this, but I'm going to go ahead and I'll be back with part 4, I think it is, and it'll just be the factoring piece.